Hello everyone, today I'm making 5-nitrovanillin, a useful and versatile nitroaldehyde building block. In my first attempt, I charged a small flask with 5 ml of cold acetic anhydride in an ice bath, then added 1.3 ml of concentrated nitric acid dropwise over about 10 minutes to generate acetyl nitrate in situ. To this stirred solution, I added a cold solution of vanillin dissolved in 10 ml of ethanol, also dropwise. As you can see here, the addition was too quick. The mixture got hot, turned very dark, and gave off some brown nitrogen oxide fumes. I immediately moved everything into the fume hood and let the vapors clear, then poured the reaction mixture into a beaker containing 30 ml of cold water to crash out the product. For my second attempt, I changed the solvent system. I dissolved 2 grams of vanillin in a minimum of cold glacial acetic acid, about 10 ml. Once everything was in solution, I added cold concentrated nitric acid dropwise with good stirring, keeping the temperature down. After the addition was complete, I left the mixture stir at room temperature for 30 minutes. To help precipitation, I then added some cold water, which gave a much cleaner yellow-orange solid compared to the first run. Mechanistically, with acetic acid and nitric acid, you're generating nitronium ion in a moderately acidic medium. The hydroxyl and methoxy groups activate the ring, giving 4-hydroxy, 3-methoxy, 5-nitrobenzaldehyde, or 5-nitrovanillin. After both reactions, I collected the solids by vacuum filtration and washed each cake with cold water to remove residual acid and acetic species. The crude yield from the acetic anhydride ethanol route was 48%, while the acetic nitric acid method gave 59%. The lower yield in the first attempt is almost certainly due to the temperature spike during the addition, hence more side reactions, decomposition, or oxidation. In the proton NMR spectrum of 5-nitrovanillin, observed is the methyl, aromatic, aldehyde, and hydroxyl signals. Zooming into the aromatic region shows the 2 doublets with a characteristic meta-coupling constant around 1.8 Hz. One doublet corresponds to H2, and the other H6 on the benzene ring. If nitration occurred elsewhere, we would see a different pattern, like a singlet or an orthocoupled doublet. A 2D NOESY experiment confirms this assignment through space. The methoxy protons show a blue cross peak to the adjacent aromatic proton, and the aldehyde proton, showing a correlation to both aromatic protons, is consistent with the expected structure. Note that this powder stains quite well, so gloves are a must. Overall, the acetic acid/nitric acid method was cleaner and higher yielding, largely because it avoided the runaway exotherm of the first attempt. Thanks so much for watching.